Yeah, today I want to talk about WASM workloads on Kubernetes. First of all, this is me. I have 15 years of experience in IT. When I started, the cloud was pretty new. So I started working with a lot of servers on premise, but at the same time, we're migrating things to the cloud, Amazon. So it was good times. I learned a lot during that period. So after that, I always worked mostly as a system administrator, DevOps engineer, platform engineer, but basically playing with Linux boxes and networks and things like that. I was born in Chile. I was raised there, but currently I live in Costa Rica. Better weather. Currently, I work as a staff engineer on a company called Veritas Automata that is based in Ohio. I do DevOps engineering as well, writing Kubernetes operators and things like that. These are where you can contact me, like LinkedIn, my GitHub account, and on Mastodon. So let's start. What is WebAssembly? Like it says, well, this is the official definition. So basically, it's a format, right? An instruction format to run on a VM. It was at the beginning focused on web browsers, but with the time it moved to server applications as well. It's meant to be portable. So you compile C++, raw, C, other languages into WebAssembly so you can run it in many places, right? Like I said, it was at the beginning meant for web workloads, like, I don't know, running Unreal games on the browser, or examples like Figma or Photoshop, where you have you need.
Christopher, we have a request to, can you make the text larger by chance? Or is that my side? Not actually. Huh?
It's not readable.
It's not readable. Yeah.
No.
It's my side. It was my side all
I
along.
was gonna wait 3 days.
Okay, yeah. Maybe I can change. Took some time.
No, you can't.
Oh,
I mean, if I move this to here. There, or too big?
yeah, that sounds good.
Uh,
Perfect. Thank you.
Nice. Let me see if I can move it. Okay, cool. So yeah, basically, like I said, WASM was meant for, that's what is why it's called WebAssembly, was meant for the browser. But with time, we found out it could be awesome for having like a standard interface for server-side applications. So this WebAssembly system interface was developed. It's a standard now. It's like a POSIX standard. It runs on browsers and different runtimes. Currently, we have like 2 preview versions, 0.1, 0.2. For many years, 0.2 was released like a stable last year. And it's meant to have like I said, like a POSIX standard where you have specific components like time, clocks, networking, or reading files to be the same overall runtime, so we can share the code on different machines, different architectures. Just to mention some runtimes, for example, that are not the browsers, we have WASM Edge, that is one of the ones I want to demo today, WAMR, and WASM Time. WASM Time is used for another tool I'm going to demo today, that is WASM Cloud. All these support both specs, but in the case of WASM Time, it's more complete on the preview number 2. Now, why in Kubernetes, right? Because the runtimes you can basically run anywhere. Like you don't have to use Kubernetes to do this. But the way for why we use Kubernetes is to schedule workloads. Like we use containers right now, but the main reason for container is because we want to distribute or manage, schedule different workloads. Containers are just like an implementation details. So the what we need, or the objective of that, is to distribute all the software we want and have high availability and resilience. So that is possible as well with WASM. We don't need like containers. Actually, with containers, you have a lot of boilerplate. Well, it's not boilerplate, but you have the operating system, like a Linux container, many other libraries. But with WASM, we can just deploy the file, and the runtime will do the rest. And so we get, because it's run in a runtime, we can get some safety measures. It's sandboxed by the kernel, right? But also by the runtime. We will see that it's very composable, so we can have like plugins. We can have other WASM components that can compose one another. Like, for example, get a plugin or something to do only HTTP request, and we attach it to our application. Like I say, are lighter than containers. With containers, you normally get a really big, small, maybe a scratch one with Rust binary. You can get 10, 20 devices, 20 megabytes of the size of the binary. With WASM, you can have the same on kilobytes. So it's really light files. And it's really good for Edge, because when you distribute this to Edge devices, size matter a lot. And we get faster cold start because we don't have to, we just go run the WASM. We don't have to start the container. And so I want to do a preview on, well, WASM preview 1. Get it small a little bit. I want to run Kind, that is like a local Kubernetes cluster for development. And there is this tool called k8s. That's not meant for production, mostly for testing. And so I can show you how this works on local. Here I have an API, basically a Rust API. It uses Tokyo, right? And it's simple. You just start an echo endpoint, right? One of the things with the first preview is, I don't know if I want to show you like the dependencies. We need to use specific branches that are meant for WASM, right? Which basically we cannot, like, if they don't upgrade the code and the libraries, we are stuck with them. So that's something I saw like as a disadvantage. But basically, like I said, the API is pretty simple. What I want to do is basically create a cluster, right? And this kind tool is create a cluster locally. Oh, there is a one already. So let's name it WASM2. It creates a cluster really fast. I'm going to use the other one. So after you create the cluster, for example, we add this WASM operator here for Helm. Helm is like the package manager for Kubernetes. And we can see we have WASM running here. This operator will let us run this test. First of all, we need to, we're going to create an annotator node. That's important because if not, it won't run. We need to make sure that this node knows where to run the WASM job. And finally, I'm going to run this example, right? And we have this one, right? It basically finished because it's a job, right? And we have this information about what it run. Okay, now what is important about this? I also have another one that I'm gonna run in this is my local laptop, but I also have a local cluster here. It's running on a RM machine. So it's different architecture. So I'm gonna run this. Give me a second. I'm gonna run this REST API I wrote here on this cluster. Second, so the first thing is like this is an Ubuntu machine, right? We need to know first. We need to install. This is more low level, so we need to install WASM-Edge and crun and verify when we run this crun command. I'm going to show you. We have the WASM-Edge runtime enabled, like this one, right? What happens if we don't? Normally, sadly, this machine is pretty old because we need some drivers, so we don't have one enabled by default, but you can basically, well, here's a little smaller. We can compile it, right? I don't know if you see it, but basically install these dependencies and then run it, compile it with WASM-Edge flag so we can have it enabled. And the last part, you need to add this file to k8s. k8s is a Kubernetes distribution I'm using. So that you can see it's pretty like hands-on. You have to do a lot of steps and make sure that you have it already like configure, enable WASM, and to be able to run it. In my case, this is already done in this cluster, and I can show you that I have the runtimes, the WASM runtime enabled. So now I can run with WASM-Edge some WASM workloads. First of all, we need to build it, right? And like you can see, it's pretty straightforward. which you can use a Scratch image Docker file. Just add the WASM file to the root of the container and just enable like the command, right? The important thing here is you need these annotations. These are OC annotations before you build it. Without this, basically you will not be able to run the container. And this is the YAML of the pod definition, so we can run it on the cluster. I have it ready here, so you can see. Right, so what's API? So you can see the pods. Awesome test, and you see their API is running as a pod, right? Like this way of doing things, like I said, it's really on hand. So you have to do this on every node. Maybe it makes sense in an on-premise where you don't have nodes like being created dynamically, like in the cloud. But that's not good, right? You want something more automated or easier to manage in cloud environments. And this comes a tool called WASM Cloud, and this support WASI like preview version 2, right? And I stole this from WASM Cloud page. Basically, the difference now, like I said, in the other module, I had to build or modify every library I had to match or to be able to be compiled on WASM. But now I can create different pieces, different components or libraries, and I can make them interact with each other. So if you need a library for Redis or for I don't know, different like gRPC or other kind of networking, you just make this like plugin and then attach it to the component. So you don't have to do it like everything in your application. And yeah, you can run it on every architecture that is supported. I already installed WASM Cloud on the cluster I'm going to show you, but basically it's pretty straightforward. You install, well, NATS is very important. NATS, it's a distributed key value store and many other things that is used for working with WASM Cloud. And because you can use it also to put it on edge devices. So if you have it in a different part, not specifically in Kubernetes, you can use this to manage it. And this way you can have your system ready for WASM Cloud. But something I want to show you before, like using WASH. Well, first of all, you have to install. Well, in my case, I'm using Rust. So you install WASH. That WASH is the tool for interacting with WASM Cloud. Make sure you get the preview number 2, right, for the WASM target. And you now can create and build an application here, right? I'm going to show you the one I already created. Here we have the WASM YAML definition, for example, which is the one is used for deploying the component. Like you can see, this where is you define your components, and here is, for example, you need HTTP, right? So you attach this component here, and this component is this capability, for example, is here. Something different you didn't write. So if you want to, let's build it, for example, you just use WASH and build, right? To build this image, you will get this WASM file. But also you can do WASM dev. Yeah. Sorry. Which will create a local environment so you can iterate faster while you develop. So you don't have to have a Kubernetes cluster or any other environment ready. You can just start working on your system. So let me go there, do some changes to our code. Component, so you can say hello from Linux Fest Northwest, right? This has hot reloading, so it will create a new image for you. Probably Rust Analyzer is giving up hard time. Let's see. Okay. We can do curl localhost, right? There it is. So you can work and iterate faster with this. But now, let's say we have it ready for the development and want to push it to a registry. We will not need to build like a container like the last time. We just deploy it directly to a registry. This can be any registry, Google, GitHub, anything. And Wash will do it for you, right? Now, whenever we are ready, for example, in this YAML file, we define the image, right? And now we can deploy it on the cluster. And now we can see the application in the cluster deploy. I deployed another one as well. And it creates services as well in the cluster. So yeah, basically that's it. Thank you very much. I don't know if you guys have any questions or comments.
Yeah, does anyone have any questions for Christopher? Okay. Christopher, I actually do have a request for you real fast. Could you go back to slides 1 through 3 for me? Just to make sure that we get it in the recording with the more enlarged font so we can see it. If you can slide back that way. If it didn't break. Chris, can you hear me? I think it busted. It was perfect timing.
Oh,
Yeah, here we go, Chris.
yeah.
There's
So,
1, 2.
let's
And
see.
can I just get 2 for like 15 seconds for you? Perfect.
There.
That should be in for the recording. Perfect. And then can I get 3? Cool. Perfect. And then one last check. Any questions for Christopher? I know I asked before, but cool. Looks like we're all good here, Christopher. Thank you for doing your talk
Thank
at
you.
Linux Fest and appreciate you. All right.
Yeah. Thank you. Bye.
Perfect.